Hello. Today we look at test for cations. Before we do the practicals, let's dig into the theory. When testing for cations, two reagents are used: sodium hydroxide and ammonia or ammonium hydroxide. Those are the two main reagents that are used to test for the cations. Now, first using sodium hydroxide. So we have the foreign cations to test: calcium ions, magnesium ions, zinc ions, aluminum ions, lead ions. We have colored ions like copper ions, iron 2 ions, iron 3 ions. Sodium hydroxide in few drops and in excess using ammonia or ammonium hydroxide in few in excess. We have two brothers which behave the same. The two brothers behave the same in sodium hydroxide. That is, then we have the three sisters who also behave the same in sodium hydroxide. So they behave the same. Then we have the other three. We call them colored ions because they show different colors in both sodium hydroxide and also in ammonia. So with the colored ions, it is very easy to know them. For the two brothers, they are white in hue, white in hue, white in hue. The sisters also white in hue, white in hue. So in an exam, you are going to hand few drops of sodium hydroxide, and it turns white. You are supposed to write the 5 cations. That is, calcium, magnesium, zinc, aluminum, and lead ions are present. Remember, ions are separated using commas. Do not use connectors like and. What about in excess? The two brothers remain white in excess. So if you are told to want 2 drops of sodium hydroxide till excess, and they turn white in few or 3 drops, white in 3 drops, and white remains or persists, then calcium and magnesium are present. We have the 3 sisters. We call them ZAP, just like Safaricom has M-Pesa, Zain have ZAP. So for the ZAP, the 3 sisters, they also behave like this. They are white, 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 then colorless, colorless, colorless. They behave the same. So by the end of sodium hydroxide, you're supposed to have the 2 brothers, that is calcium and magnesium separately, and the 3 sisters, the ZAP, that is zinc, aluminum, and lead ions, because they look different. So the other separation of the 5 cations will be done using ammonia. Then for the colored ions, there is no big problem because they have their own colors. Like copper ions are blue in color when in solution form, as we will see. Then green is ion 2 ions, and copper and ion 3 ions are brown in color when in solution form. So when you hand sodium hydroxide, they'll still maintain their color: blue, green, and brown. When you add in excess, they will still maintain their color. Then, when you are told to use ammonium hydroxide, it is mainly to separate further the two brothers and the three sisters. Now that we have been able to know copper ion 2 and ion 3 ions, since we have different colors, using ammonia or ammonium hydroxide. There are one color which starts with a C is colorless. So colorless. Then the rest of the brothers, you write white. The easiest way of understanding this. Then for the three sisters, we have the first one here, which is zinc. So zinc is white in field and colorless in excess. The other colors are white, white, white. So for the three sisters, we have been able to separate zinc from the rest. Now what we have not been able to separate are the lead ions and aluminum ions, which we are going to separate in another test. Then for the colored ions, this is blue in color. In fact, this one deepens, it becomes a deep blue color, as we will see. Then this one remains green, this one becomes green, this one is brown, and this one is brown. And sometimes you are given ion 2 ions and you are told to add hydrogen peroxide. When you see the brown precipitate, it does not mean that ion 3 ions are present, because you are the one who have made the ion 3 ions. It just confirms the presence of ion 2 ions. So you say ion 2 ions are confirmed. Then now that we are not able to separate aluminum and lead ions, we go to the third test. So the first test is using sodium hydroxide. The second test is using ammonium hydroxide, whereby we have been able to separate the two brothers, calcium and magnesium, and we are also able to separate the zinc from the other sisters. So the third test is called lead test, which helps us now to know when lead ions are present. So when all these tests becomes positive, then it means that the lead ions are present. The first chemical we use are sulfate ions from sulfuric acid, sodium sulfate, potassium sulfate, etc. Any sulfate that contains sulfate ions. If they turn white, then lead ions are present. And in case they don't turn white, it means aluminium are present. In these questions, in paper 3 questions, cations and in qualitative analysis, we always emphasize on positive answer. So it is better you say aluminium ions present than you say lead ions are absent. Avoid absent if you can have present. Chloride ions from hydrochloric acid, sodium chloride, potassium chloride, etc. If they also turn white, then lead ions are present. Then we have iodide ions, you get them from potassium iodide, sodium iodide, etc. And if the solution turns yellow or forms yellow precipitate, then lead ions are present, as we will see. Then, in case of chloride ions, chromate ions from potassium bicarbonate 6, if they also turn yellow, then there is lead in that solution. Let us now click into the practicals. Shalom.